Hello everyone, Dr. White here with some solutions for the sections 1.3 and 4 DA. So let's go ahead and grab them from the common folder. /com, Dr. White stuff, Math 111, old DAs worked by Dr. White. I'll go ahead and open up the R Markdown just in case I want to have a look inside it. But mostly I'll just view the HTML version here. Click on it, say View in Web Browser. Okay. Your first question was on the bifocals and prostate cancer hypothetical observational study. And you were asked, what's the explanatory variable in the study? Well, someone might think that wearing bifocals could have some effect on whether or not you have prostate cancer. And so you could say that bifocals is the explanatory variable and prostate is the response. Second question, well, if that's how you're thinking of it, then could there be a confounding variable in the study that explains the association described in the problem between the bifocals and the prostate cancer? This association here, where the men who wore bifocals had prostate cancer at a higher rate than men who did not. What other variable could explain this? Well, one possible confounding variable would be age. Now you notice I have this explanation for why it's a confounding variable. As I've emphasized in class, this explanation is based on the definition of confounding variable. If I could take you back to our slides for a little bit, to around slide 26, this is a graph that shows the definition of a confounding variable. This confounding variable in green here is a third variable, different from the explanatory variable and from the response variable. Secondly, it is associated with the explanatory variable. Thirdly, it helps to cause the response. So if we want to justify why age is a confounding variable in the study, then we need to address those three things. Back to the solutions. Well, I point out that it's a third variable different from the explanatory and the response. I probably didn't need to do that. It's obvious to most people that age is different from the prostate variable and different from the bifocals variable. But I do really need to address how it's associated with the explanatory variable. Well, I need to get specific about why it is. Well, bifocals, older people are just more likely to wear bifocals, The older you get, the worse your vision gets. So the more likely you are to wear glasses and thus to wear bifocals. I'll point out that it's also not caused by the response. That's actually part of the definition of confounding variable. Wearing bifocals won't change your age, so it's not caused by the explanatory variable. But thirdly, age does help to cause the response variable, prostate, because the older you are, the more likely you are to have developed cancer of all sorts, including prostate cancer. So I've addressed those conditions. I have explained how age can be a confounding factor in the study. That's probably what's going on in this study. It's not the bifocals that make people get cancer. It's just that older people get cancer and older people are wearing bifocals more. Next problem was vitamin C and colds, and you had this lead-up information, which I suggest you stop the screencast and read it again before proceeding to the solutions. First question was this an experiment or observational study, and why? Well, it's an experiment, but to explain why it's an experiment, we have to specifically say why it meets the conditions of the definition for an experiment. By definition, an experiment is a study where the researchers assign the values of the explanatory variable to the subjects. So I get specific. I say the explanatory variable here is the amount of aspirin taken, like none for the placebo, or 1 gram, or 3 grams, or 3 grams plus additives. And we see from the scenario information that subjects were assigned to take certain amounts. A fourth of the patients were assigned to take a placebo, and the rest were evenly divided between these other 3 groups. So there's 100 in each group. Researchers did the assigning, so this is an experiment. Next question, part B. What are the explanatory and response variables in the study? If the study is an experiment, identify the factor and status levels. So the explanatory variable we've already seen. It's what group you're in, how much aspirin you're prescribed to take when you have a cold. In the book and the slides, they tell you that another name for an explanatory variable is the factor. So that's the factor in the experiment. Levels, by definition, are the values of the explanatory variable. So that would be the 4 groups. Taking a placebo, taking 1 gram of vitamin C, taking 3 grams of vitamin C, taking 3 grams of vitamin C in your pill, plus your additives. Let's see. It's also asked in here, what are the response variables in the study? So looking into the scenario information, we see at the end, no significant differences were observed in any measure of cold duration or severity between the 4 groups. So it looks like they're measuring how long are the colds and how severe are the colds. So I think they've got two response variables there: duration of cold and severity of cold. Next, in part C, were the patients blinded to their treatment, and how can you tell? Well, in the lead-up information, it says that, let me see if I can find it here. Oh, all tablets had identical appearance and packaging. So when you're a subject in the experiment and you're taking a tablet, you can't tell what's inside of it. You can't tell whether it's a 1 gram or a 3 gram or a placebo or what. So the subjects do not know what group they're in. That's the definition of blinding. So here's my answer, and I state specifically what I saw in the scenario information that grounded my response. Was the study double-blind? So they're asking, was it blinded on the researcher side as well as on the subject side? And how can I tell this? Well, I look back in the scenario information again, and I found this. The nurses who were handed the prescribed pills to the patient, the nurses who handed the prescribed pills to the patients knew which patient received which treatment, but the researchers assessing the patients when they were sick did not. Okay, so now I can see that the people who measured the response variables, the duration and severity of the colds, they were blinded. The nurses knew, but those weren't the people who were, evaluating the response variables. So there we go. The experiment is double-blinded. Last question is an interesting one. Participants are ultimately able to choose whether or not to use the pills prescribed to them. We might expect that not all of them will adhere and take their pills. Does this introduce a confounding variable to the study? Explain your reasoning. Well, if the subjects knew what type of pills they were given, or if they could somehow learn that during the course of the experiment, then yes, we could get a confounding variable in the study. The variable whether or not one takes one's pills as directed could be a confounding variable. Now, why is this so? Let's address it with the definition of confounding variable. I need to argue that it could be associated with the explanatory variable and that it helps to cause the response. In this paragraph, I argue that it could be associated with the explanatory variable. For example, if somebody were to learn that, she's prescribed a placebo to take, but that others have been prescribed pills with vitamin C and vitamin C with additives, then she could just decide, hey, why take this placebo? It's not going to do anything. And she could go out and purchase vitamin C and additives to take when she has a cold so that she could get those same benefits. On the other hand, a subject who knows that she is assigned to the 3 grams plus additives group, she wouldn't have any motive to go out and purchase other treatments. So she would have more motive to just take pills as directed. So then the two groups would differ in how likely they are to take pills as directed. And so you would get an association between whether or not you do what's directed and what group you're in. Next up, in this short paragraph, I point out that it could cause the response. If vitamin C actually does make colds less long, make them less severe or whatever, then whether or not you take your vitamin C as directed can affect whether and how long your cold is. So that one's pretty easy. So if people could know their groups, we could get that association, and we already have the causation. So we get that taking pills, whether or not you take pills as directed, would be a confounding variable. But that can't happen in this situation, I think. And that's because the experiment was blinded, right? We already learned that. The subjects didn't know their groups. So there's no way that the variable, whether or not one takes one's pills as directed, could be a confounding variable, unless the subjects could somehow learn what group they were in during the course of the experiment, like if maybe if they pressed the nurses to tell them what the pills were or something like that. But it's really difficult to see how that could happen. So I'm going to stick with no, it can't be a confounding variable in this experiment. So the key really is the blinding. And that's why you always try to blind an experiment if it is feasible to do so. That's all I've got for these solutions. See you later.